Now moving into integration properties, of course, same as derivation, integration have properties, how to manipulate integration when they are multiplied, added, or subtracted, or divided, and so on. So a constant factor can be moved to the front of an indefinite integral. So now you have indefinite integral that's not identified, doesn't have a top or bottom limits. If you have integration of constant c multiplied by the function f of x dx, you can kick out the c outside the integration so that you can do the integration in a simpler form, and whenever you finish integration you go back to that constant and multiply it by the result. So that would equal c multiplied by the integration of f of x dx. The second rule, the antiderivative or the integration of a sum or a difference is the sum of the difference of the antiderivative. Doesn't make sense, but let's go over here to have the sense out of it. The integration of f of x, let's say in this case plus g of x dx, you can distribute the integration on the function f of x and gx as long there is an addition or subtraction for that function. So that would equal the integration of f of x dx plus the integration of gx dx. If you have the integration of f of x minus gx dx, then you would as well, you can distribute the integration, so you can do the integration of f of x dx on the side minus the integration of g of x dx on the side, and sum the results together and get your final answer. Let's take an example on that kind of properties for integration. You have an integration of triple functions over here that are added to each other. Function 1 is 3x to the power of 5 plus 7x to the power of 2 or squared plus 8 dx. Distribute the integration on function 1, 2, and 3 since there is an addition. So I can say the integration of 3 of x to the power of 5 dx plus the integration of 7x squared dx plus the integration of 8 dx. This way it's easier for me to handle each function alone and add the final result together. What is the integration of this power rule? It is a constant multiplied by a function that relates to the power rule. So I would push that constant outside, in this case 3, multiplied by integration of x to the power of 5. We know that's a power rule. That's 1 over 6, which is 5 plus 1. 1 over 6 multiplied by x to the power of 5 plus 1. That's x to the power of 6. Go next. You have a constant and a power rule, or a function with a power here that we can have the power rule applied to it. The final answer would be 7 multiplied by 1 over 2 plus 1 multiplied by x to the power of 2 plus 1. Plus 8 as a constant would result as 8x. Now put everything back together. You will have always, each integration you will have a c. So you'll have a c here, plus c here, plus c here, and plus c here. All can be represented as one c at the end. So you have all the final answers for each function plus c, which is the constant of integration in this case. Another example of division: 4 plus 3x plus 2x to the power 4 over x dx. What is the integration of that function? Try to simplify the form. Divide all of these over x. Since you are adding in denominator, you can divide each function on the denominator and get life easier for you. That's 4 over x plus 3 plus 2x cubed dx. Then you can distribute the integration of 4 over x dx plus the integration of 3 over x plus the integration of 3 dx plus the integration of 2x to the power of 3 dx, and get your final answers based on the table, and you'll be good to go. So if we take, this is the first time we mention it here, let's take the 4x. So here we have the indefinite integration of 4 over x dx plus the integration of 3 dx plus the integration of 2x cubed dx. Now this one, that's a constant over here, the 4. We can get the 4 outside, so 4 multiplied by the integration of 1 over x, because 4 by 1 over x equals 4 over x. So you got the 4 outside dx. Now what is the integration here? We put the 4 as it is. 1 over x dx, if we go back to integration rules, it equals the ln of x plus c. So this function value is for the len of x plus c. Here, so that's plus, we have 3, it will be 3x plus c, and we have here plus, of course, 2 to the x cube, in this case 2 multiplied by 1 over 3 plus 1 multiplied by x to the power 4 plus c. As we said, those c's will be unified together, so everything will be plus c, 1c only, you don't put 2c, 3c, whatever. So you have 4 len of x plus 3x plus 2 over 4, that's, you can be simplified as 1 over 2, or you can keep it as 2 over 4, it's up to you, x to the power 4 plus c. And this final answer is exactly identical to this final answer over here. So you should be good to go. Now we have an example. Find a function f such that the f prime of x equals 2x plus 3 and the f1 equals minus 2. When he say find f such that f prime equals this, that means find the integration of this function. So you can see here the integration of 2x plus 3, what would it be? So you can see here the integration of 2x plus 3 dx, that would give you x squared plus 3x plus c. So that's the first term of the question. You have f of 1 equals to minus 2. Then in this case, if we plug in the final answer, so we have here the f of x equals x squared plus 3x plus c as a result of our integration. The f of 1 equals minus 2, so here we have x as 1 and f of x, or the y, as minus 2. So in this case, we plug in the numbers. Minus 2, which is the f of 1, equals 1 squared instead of x squared, plus 3 multiplied by 1 plus c. In this case, we can find the value of c by equalizing the two parts of the equation. C in this case would equal minus 6. You can go back. If you get this kind of question, you can go back. He expects you to plug in the value of c over here to the final answer to get the final mark, or to be considered as solving the problem in a fully manner. Now let's take a physical example. A rock that's thrown directly upward with an initial velocity of 50 feet per second from an initial height of 10 feet. So somebody was standing 10 feet high from the ground and he threw a ball or a rock upward in an initial velocity of 50 feet per second. Now the velocity of the rock is modeled by the function, which means represented by a function of v of t. So the velocity is a function in terms of t, equals minus 32t plus 50. Don't be confused by the t, you can imagine it as f of x equals minus 32x plus 50, same thing. But he's seeing here, which makes sense, the velocity as a function of time. Physically correct than having f of x. V of t equals minus 32t plus 50. T is in seconds because it's time. V is in feet per second because it's velocity. And t equals 0 represents the moment the rock is released, because at time 0, that's when the rock been released. So first he asks you to determine the distance function h as a function of t. So you need to find the distance. Distance in this case is the same as the height, of course. Be sure in this case to consider the fact that t equals 0. The rock was 10 feet high, or 10 feet above the ground. So the distance or the height here, h of t, would be a function of velocity. H of t would be the integration of the velocity. Why? Remember when we said the derivation of velocity physically equals the distance. And here the distance is being done upward or in the y-axis, which could be considered as height. So the height is the integration of the velocity function in this case. So the height equals the integration of minus 32t plus 50 dt instead of dx, if you remember, because we're talking here in terms of time. Doing the integration, following back the integration table, would give you minus 60t squared plus 50t plus c. Now we already know that we started with a height of 10 that we can plug in here instead of h of t, and we have the time 0 at the moment the rock was released. So if we plug these in, then we can find the constant C equals to 10. You go back here, you plug in the 10 instead of C, and you will be considered having fully solved the branch A of the example. In branch B, he's asking you to determine the height and the velocity of the rock after 3 seconds. So when t was equal to 3, what was the height? You already have the function of height. H of t equals minus 16 t squared plus 50t plus c, in this case plus 10. Then h of 3 would give you the height, and v of 3 over here from what's given in the question would give you the velocity. So you can see h of 3 gave you 16 feet, v of 3 gave you minus 46 feet per second. Hopefully that's clear. If not, if you're not familiar with the physical problems, or you didn't take physics 101 previously, then that's totally fine. You're not supposed to understand that. But if you do, then that's a good addition to your mathematical or physical dictionary, or a science dictionary in this case, of how to solve or how to use the integration in solving physical problems.